Okay, thank you very much and welcome. My name is Chris Agonas Odhiambo, and I'm afraid I'm getting this video done at night, and uh, I don't have much time to polish up, so I'm not going to focus much on the video. I'm going to focus much in the content or the subject of this video. Um, for those who have a background, what I'm doing here, this is a, a culmination of the Google AI Capstone, sorry, Google AI generative AI training, intensive training, and this is about the Capstone project at the end of this um, 1 week training. So I'm going to go straight to the idea that we have implemented using GenAI, and this idea is called QwikSense. That's the name I gave to it, and I'm gonna, because time is not on my side, so I'm gonna go straight way to introduce the idea. Um, Now, we live in an era where there's just so much information. We are literally drowning in data, literally. And every day, from your phone to your emails um, to your social media accounts to any other gadget you're using, from your car to everywhere else, there's just a whole lake or sea of data that is literally drowning you all the time. And generally, majority folks are poorly equipped to deal with this information deluge. So, in the era dominated by digital media, the consumption of video and audio content, and even text as well, is gone up many times. And the platforms like YouTube, Netflix, podcasts, and e learning modules have become integral to education, entertainment, and professional development. However, this surge in content availability has also led to significant challenges for consumers. And the sheer volume of media, coupled with the prevalence of redundant, repetitive, or irrelevant material, has made it increasingly difficult for users to efficiently extract meaningful information. And this inefficiency not only wastes time, but also diminishes the overall quality of the content consumption experience. And the problem of information overload is not new. The phenomenon of information overload is well documented in the digital age, and studies have shown that an average person, uh, an average person spends several hours daily consuming video and audio content, not to mention text content, just reading material or listening to material or just watching material. For instance, educational videos often revisit concepts multiple times for emphasis, while podcasts and interviews frequently include filler words, off topic discussions, or lengthy introductions. These inefficiencies can lead to cognitive fatigue, reduced retention, and a sense of frustration among users, and therefore the need for intelligent content summarization. And this is where the QwikSense comes in. While tools exist to adjust playback speed or skip sections manually, they lack the intelligence to automatically identify and prioritize meaningful content. Uh, current current solutions do not address the core issue of detecting um, and eliminating redundancies or irrelevant material. As a result, users are left to navigate vast amounts of content manually, which is both time consuming and impractical. I don't know how you consume media generally, but when I'm listening to any audio or watching some video or reading some material, there are many moments when I have got to skip some sections and just try to rush myself because that's the familiar content. I've consumed it elsewhere. Maybe I'm watching news. I watch something on CNN. A reporter doing some reporting on CNN. I go to MSNBC. I go to BBC or whatever else, and I get some some vlogger, and I find, in a sense, they're talking about the same thing semantically, but they're just different reporters. So there are so many ways in which there's information overlap in all these videos and audios. And so I'm forced as a user or a consumer to keep looking for how to skip all these sections, and this can be very dramatic and just so disruptive. How about if we just take this task of just skipping around content, identify what a user's consumed, and therefore automatically and smartly just skip it, and yet continue to maintain the semantics of information. Because as we chop off, sections of content, we can compromise the semantics, the meaning of content. And so as we do this intelligent seeking and skipping, is crucial that we maintain the meaning, the overall meaning of information. And this is where QwikSense comes in. So the role of AI in enhancing media consumption, advancement in AI and natural language processing present a unique opportunity to address these challenges. By leveraging AI-driven techniques such as speech-to-text conversion, topic detection, and repetition identification, it is possible to create tools that intelligently summarize and streamline content. Such tools could automatically detect key topics, skip repetitive sections, and enable users to customize their viewing or listening experience based on personal preferences, or even in some cases based on their community preferences. Assume that I belong to a community of some 1,000 people. Maybe I belong to a college. I'm a member of a college where I meet some folks, some friends of mine. And so the manner in which they consume content sometimes can determine what content I consume as well. If they have consumed something, and then history shows that I don't spend much time consuming what they've consumed, which means that likely we have had a conversation, and I've listened or heard about that content from the conversations among ourselves, then likely I'm going to skip that content when I come to the content playback. So the user consumption can actually be determined by the user's history. In other words, what the user has consumed previously, as well as what the user's community has consumed. So there's a lot more to be mined out of this. But what we have tried to achieve in this case is basically to present a proof of concept. There's another part of this work which is gone on to productionize the whole thing and make it a tool available in so many ways. But over here, I'm going to switch over to um, I'm going to switch over to Kaggle, the Kaggle notebook, and I'm not going to spend much time on this because it's available publicly, and you can take a look at it in the vlog, in the blog that I also share with this submission. So just quick straight to see what I'm talking about. I'm going to show you the Kaggle. So if you can see my screen. Right, if you can see my screen, let's go to the Kaggle. A brief introduction to the whole idea, and then I explain basically the choice of vector database we're using here, which is FAISS. And FAISS is Facebook AI Similarity Search. Is a vector database and very appropriate for use here, especially because we're looking at low latency, high performance, because when people are consuming content, it ought to be much like real time. So this is important because the user experience is very important as far as this is concerned. And then, there's some libraries to be installed. So make sure that you install the library. After installing the library, in case you experience some challenges, just restart your kernel. And then just, import the SDK for the GenAI, google-genai. Set up the API configurations, which is down there. And then explore the available models, just to be sure to know what models you have available for use. And then straight away we go to come up with some helper function for embedding, because all this content before it goes over to the vector database is embedded. Before we do any comparison, we create embeddings for the input content. So as you can imagine, there's the incoming content from maybe a video or some audio, and there's the existing historical content. In other words, there's some history of the user's previous accessed information. So what's coming in is basically what's being compared against the history, and whatever is on overlapping on that history is going to be chopped off the incoming content, and that's what gets served over to the user with an overriding requirement that the content semantics, in other words, the meaning, is preserved. So where the meaning is going to be compromised, then a lot of that content is going to be retained, even if it's repetitive. Um, okay, so this is text chunking. If it's long text, it's got to be chunked, and then there's vector database initialization. There's redundancy detection, filtering logic. So this is essentially where we identify what is repetitive in the incoming text or content, and then eliminate that, and then return cleaned up text. Then this now the experiments, the simulation of continuous consumption and history update. I want you to think of this like I have my headphones, I'm listening to content, I'm doing some cooking, I'm driving, but then the AI is playing in the background. It's just like evaluating what's coming in, comparing against the history and deciding to skip smartly, and so putting my attention to what is important. I want you to imagine this tool in the hands of students who are preparing for exams. They don't have much time. They're only focusing on what is useful, what's new. I want you to put this tool in your hands. You are listening to a whole litany of news items in the day, and you don't want to spend too much time on repeating yourself on videos and audios you've listened to before. Your hands are busy, your mind is busy, you don't want distractions, so you focus your attention on whatever you're doing and let the tool do its job in the background. So it's just busy, picking, comparing, returning, filtering, and serving you what you need. And then, of course, we're going to have some configurations to determine just to what degree you do the summarization. Is it very strict? Is it less strict? And how much do you summarize? All those things. Anyway, these are just experiment examples. It shows you how this tool is able to eliminate repetitive information, and then eventually how you can use it to summarize the eventual output. The concept implemented here in this tool for us, embedding vector databases, prompt engineering, and also let me tell you what else. Uh, Yes. Yeah. What else? Yeah. So foundational models and prompting, embeddings and vector stores databases, and then domain-specific LLMs. Anyway, so time is running out. I gotta get this out of the way before I'm out of time. So thank you very much. Please, for more information, go look at the vlog. I put the vlog here, the blog. This is the blog. I'm going to share this as well in the submission. Making this public. It's available to everyone who can access this on a read-only basis. And I also put my LinkedIn down there, and I also put my YouTube access. I'm going to put YouTube link here when I upload this video. Thank you very much. It's been a wonderful experience, and I hope that I'm going to get this out of the way and upload this to something that people are able to find um, useful. Thanks, everyone. Thanks for your time. And window capture, I'll go back to myself. Okay. All right. Appreciate your time. And it was a time to learn something. And this tool is still way far away. It's going to go to production, so there's a lot more work to be done on it. As I said, there's another version of it running parallel in development. But I do hope that you're able to get a gist of QwikSense. Cut to the chase. Leave off the clutter. Avoid binge video consumption, and get to the material that is novel. And save time. Be focused. Be more productive. Thank you very much. Adios.